In this lecture, I am going to present what is hybrid structures and how to determine the static indeterminacy of the hybrid structures by using two approaches. Then I would like to solve two problems on hybrid structures. First, coming to what is hybrid structure. Skeletal structures having some of the joints as pin connected and others as rigid connected are known as hybrid structure. Hybrid structures are such type of structure where both trusses and flexural frames or beams connected together. This is the example of the hybrid structures. So in this figure, this is the truss and this is the beam, and these two is connected by a bar. So this is a hybrid structure. So here the supports A is hinge support and B is roller support and E is fixed support. These are the pin joints. A, B, C, D, these are pin joint, and E is the rigid joint, and these are the members. And look at this figure. So here the support A, E, L, N, these are the fixed ends, fixed supports, and M is a hinge support, or this is treated as a pin joint, and these are the pin joints. These are the pin joints. B, F, I, D, H, K, these are the pin joints, and C, G, J, these are the rigid joints, and these all are the members. Then coming to what is static indeterminacy, then how to find out the static indeterminacy of hybrid structures. So first you have to know what is static indeterminacy. When the number of independent reaction components is greater than the number of independent equations of equilibrium, the equilibrium equations are not sufficient for the determination of unknown reaction components. These structures known as statically indeterminate, hyperstatic, or redundant structures. These structures may be analyzed by writing additional equations of compatibility of deformation. The number of equations of equilibrium falls shorter than the number of unknown reaction components is known as the degree of static indeterminacy or the degree of redundancy. There are two different approaches may be used for the determination of degree of static indeterminacy of the hybrid structures. Then coming to the first approach. In this approach, the total degree of static indeterminacy is equal to the sum of degree of external and internal indeterminacies. That is degree of static external indeterminacy. This can be denoted by capital D and subscript SC. Then degree of static internal indeterminacy, and this can be denoted by capital D and the subscript small si. Then the total degree of static indeterminacy can be determined by using this equation. That is DSC is equal to DSC plus DSI. Then first coming to the external indeterminacy. How you have to find out the external indeterminacy of a structure. The external indeterminacy is related to the support system of the structure. If the number of independent reaction components is more than the available equation, the structure is externally indeterminate. Then the degree of static external indeterminacy for plane structure can be determined by using this expression. DSC is equal to R minus 3, where R is the number of reaction components. Similarly, the degree of static external indeterminacy for space structure can be determined by using this expression. DSC is equal to R minus 6, where R is the number of reaction components. Then coming to the internal indeterminacy, how you have to find out the static internal indeterminacy of hybrid structure. To determine the degree of internal indeterminacy of the hybrid structures, the pin joints may in the first instance be replaced by rigid joints. Considering a plane frame, the number of independent reaction components that must be added to convert a pin joint into a rigid joint is m-1, where m is the number of members meeting at that joint. Similarly, in the case of space structure, the number of independent reaction components which must be added to convert a pin joint into a rigid joint is 3m-1. Hence, the number of independent reaction components required to replace a plane structure with hybrid joints by a rigid jointed structure is summation of m-1, where summation has to be carried out for all the pin joints in the hybrid structures. As we know, the degree of internal indeterminacy of a rigid jointed plane frame is 3C. 3 into the number of chords required to make the structure open configuration. Then the degree of static internal indeterminacy of a plane frame with a hybrid joint can be determined by using this expression. DSI is equal to 3C minus summation of m-1. C is the number of chords, m is the number of members meeting at the joint. Then, as we know, the degree of static internal indeterminacy of a rigid jointed space frame is 6 into C. You can determine the degree of static internal indeterminacy of space frame with a hybrid joint is equal to DSI is equal to 6C minus summation of 3 into m-1, where C is the number of chords required to make the structure open configuration and m is equal to number of members meeting at that joint. Then after knowing the DSC and DSI, then you can determine the degree of static indeterminacy. DSC is equal to DSC plus DSI. Then coming to the alternative approach, the second approach. So in this approach, you can find out the degree of static indeterminacy by knowing the unknown internal forces and the number of equation of static equilibrium. Then these two difference, the number of unknown forces minus the total number of equation of static equilibrium give the degree of static indeterminacy. A hybrid structure having a combination of pin joints and rigid joints. The number of unknown internal forces in a member of a plane frame or space frame depends upon the end conditions as shown in table 1. So this is the table. So here given for different end conditions of the member, given the number of unknown member forces for plane frame and for space frame. First we will consider rigid joints at both ends. If both ends are rigid jointed, so that case the number of unknown member forces for plane frame you have to take 3 and number of unknown member forces for space frame you have to take 6. Then the second, if one end is rigid jointed and the other end is pin jointed, that is rigid joint at one end and pin joint at the other end. This one is rigid joint and this one is pin joint. So this case the number of unknown member forces for plane frame that you have to take 2 and number of unknown member forces for space frame you have to take 3. Then the third one, so if both ends are pin joint, that is pin joints at both ends. So this is pin joint and this is pin joint. For this type of structure, the number of unknown member forces you have to take for plane frame 1 and for space frame is also you have to take 1. These are the unknown member forces for different end conditions that you have to use, and you have to find out the total number of unknown member forces for different end conditions. Hence, the total number of unknowns, which is equal to the sum of unknown member forces and the external reaction components. So you can find out the total number of unknown, that is by taking the sum of unknown member forces and the external reaction components. You have to find out the total number of external reaction components, and you have to find out the total number of unknown member forces. Then the summation of these two unknown member forces and the external reaction component, that give the total number of unknowns. Then you have to find out the number of equations of static equilibrium for different types of joint of the frame, and this is given in the table 2. So this is the table 2. So here given the number of static equilibrium equations for different types of joint. The first column indicates the serial number, second column indicates the type of joint, and third column and fourth column, this is given the number of equations of static equilibrium for plane frame and space frame. First one, if the joint is rigid joint, if the joint is rigid joint, that is fixed support, or this is the rigid joint, this is the rigid joint, because this is one member, this is another member, and this is rigidly connected, or if the end of the support is rigid, so this case, so you have to take the number of equations of static equilibrium for plane frame 3 and for space frame 6. Then coming to the second one, pin joint. If the end is pin jointed, or this is one member, this is another member, and these two member is connected by means of pin joint. So this case, so you have to take the number of equations of static equilibrium for plane frame 2 and for space frame 3. And by using the number of equations of static equilibrium for different types of joint, then you can find out the total number of static equilibrium equation for the complete structure. The number of equations of static equilibrium for different types of joint of the frame can be determined by using the table 2. Already I have explained. And the total number of equations of static equilibrium of the entire frame may be calculated. So this is table 1 already explained, this is table 2 already explained. Then after knowing the total number of unknown forces and the total number of equations of static equilibrium, then you can find out the degree of static indeterminacy. The degree of static indeterminacy is equal to total number of unknown forces minus the total number of equations of static equilibrium. So this is the method. So using this method also you can find out the degree of static indeterminacy of hybrid structures. Then coming to the first problem, determine the degree of static indeterminacy of the hybrid plane frame. So this is the hybrid plane frame, and here the support A, E, L and are fixed support, and M is the hinge support or pin support, and B, F, I, D, H, K, these are the pin joints. These are the pin joints, and C, G, J, these are the rigid joints, and these are the members. These are the members. So here you have to find out the degree of static indeterminacy by using the two approaches. So first we'll go for the first approach. So in first approach, So first you have to find out the total number of independent external reaction components, that is R. So here you see, so this is fixed support, here the total number of reaction components are equal to 3, and this is also fixed support, here also the total number of reaction components 3, and this is fixed support, here also the number of reaction components 3, and here also the number of reaction components 3, and this is the hinge support or pin support, and here the number of reaction components are equal to 2. So total number of reaction component is equal to 3 plus 3 plus 3 plus 2 plus 3. That is 3 into 4 plus 2. So the total number of reaction component is equal to 14. Then find out the degree of external indeterminacy. The degree of static external indeterminacy is equal to R minus 3. So where R is equal to 14, 14 minus 3 is equal to 11. Then find out the unknown member forces. But here you have to count the number of pin joints. So how many pin joints are here? Here you see, these are the pin joints B, F, I, M, K, H, D. So these 7 are the pin joints B, F, I, M, K, H, D. These 7 joints are the pin joints. And here you have to see, so you have to find out the number of joints where how many members meet. The number of members meeting at each of the pin joints. So here at B there are 3 members meeting, and at F there are 3 members meeting, and at D there are 3 members meeting, and at H there are 3 members meeting, and at M there are 3 members meeting. So B, F, M, H, D. So in these joints there are 3 members meeting, B, D, F, H, M. There are 3 members meeting. Similarly, find out the number of members meeting at each of the pin joint, that is 4. This joint, so here how many members meeting? So here there are 4 members meeting. This is 1 member, 2nd member, 3rd member, 4th member. So I joint where 4 members meet, and the K joint, here also 4 members meet. So this is 1st member, 2nd member, 3rd member, and 4th member. 4 members meet. So I and K, these 2 joints where 4 members meeting. The number of members meeting at each of the pin joint IK, this is equal to 4. Then you have to find out the summation of M minus 1. As I said, the number of members meeting at each of the pin joint. So you have to find out the summation of M minus 1. The number of members meeting at each of the pin joint B, D, F, H, M. So here the number of members meeting is 3, and at IK the number of members meeting, that is 4. So you have to find out here, this is 5 joints. At the 5 joints the number of members meeting is 3, and at the 2 joints the number of members meeting 4. So you have to find out 5 into 3 minus 1 plus 2 into 4 minus 1. So at the 2 joints there are 4 members meeting. So 2 into 4 minus 1, and here 5 joints where 3 members are meeting. So 5 into 3 minus 1. Then you have to find out the summation of M minus 1. So this is equal to 5 into 2 plus 2 into 3. 5 into 2, this is equal to 10, and 2 into 3, this is equal to 6. So the total summation of M minus 1 is equal to 16. You know, in the case of plane frame, you can find out the degree of static internal indeterminacy by using the expression dSi is equal to 3c. But in the case of hybrid structure, and you have to find out the degree of static indeterminacy by taking 3c minus summation of M minus 1. So you have to deduct the summation of M minus 1 from the expression 3c. In the case of hybrid structures, the degree of static internal indeterminacy that you can determine by taking this expression. DSI is equal to 3C minus summation of m minus 1. So you have to deduct this one, summation of m minus 1, so that you can find out what is the degree of static internal indeterminacy. You have to count the number of chords. How many chords required to make the structure is your open configuration. If you cut here, so this become the open. If you cut here, 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 this become the open. And if you cut here, this become the open. Then, after taking the 6 chords, the structure become the open configuration. So here C is equal to 6. Here you have to take the C is equal to 6. Then you can find out what is the degree of static internal indeterminacy. So 3 into 6 minus 16. So already you got the summation of m minus 1 here. Summation of m minus 1, so this is equal to 6. The summation of m minus 1 is equal to 16. So already you got here. Then you have to put here in this expression. Then you have to find out the degree of static internal indeterminacy. This is equal to 3 into 6 minus 16. So this is equal to 2. 6 into 3, 18 minus 16 is equal to 2. Then after knowing the degree of static internal indeterminacy, and already you know the degree of static external indeterminacy 11, then you can find out the degree of static indeterminacy. So degree of static indeterminacy is equal to ds is equal to dsc plus dsi. So dsc is equal to 11 and dsi is equal to 2. So 11 plus 2 is equal to 13. So this is the degree of static indeterminacy of this hybrid structure. Then you can also find out by using the second approach. So what is the degree of static indeterminacy of hybrid structure? In this approach, you have to find out the total number of unknowns and total number of equilibrium equations. The total number of unknowns that you can find out from the member and from the support reactions. That is, you have to find out the member forces and the support reactions. The number of members with rigid joint at both ends. So how many members with both ends are rigid jointed? CG and GJ. This is C. So CG and GJ, so these two members both ends are rigid jointed. Then you have to see how many members, one end is rigid and other end is pin joint. Count here. This is 1, this is 2, this is 3, this is 4, then this is 5, then this is 6, this is 7, and this is 8, and this is 9, and this is 10, and this one is 11, rigid and pin. So total is 11. That is, one end is fixed and the other end is pin. That is, one end is rigidly connected, and the other end is pin connected. So the number of members are equal to 11. This. Then you have to count the number of members with pin joint at both ends. So this is 6, BF, FI, DH, SK, IM and KM. So these are the members. So here both ends are pin jointed. Just to see. Here you see both ends are pin jointed. This is pin joint, this is pin joint. This is one, this is pin, pin. Second, this is pin, pin. This is third, this is pin, pin. Fourth, and this one is pin, pin joint. Fifth, this one is pin joint, pin joint. This is sixth. So 1, 2, 3, 4, 5, 6. So 6 members where both ends are pin joints. So the number of members with pin joints at both ends is equal to 6. Then after knowing this one, then you can find out the total number of unknown member forces. If both ends are rigidly connected, so how many member forces? You know already from the table 1. Table 1. So if both ends are rigidly connected, for plane frame, how many unknown member forces? 3. and if one end is rigidly connected and other end is pin connected, number of unknown member forces for plane frame, this is 2, and if both ends are pin connected or pin joint, in this case the number of unknown member forces is equal to 1, 3 to 1. So just to put this value here. So here both ends are rigidly connected, 2 into 3, and one end is rigid connected, other end is pin connected, 11 into 2, and here both ends are pin connected, so 6 into 1, 2 into 3 plus 11 into 2 plus 6 into 1, this is equal to 34. So this is the total number of unknown member forces. Then find out the total number of external reaction components. So already we got the total number of external reaction components because there are 4 fixed joints, 4 into 3 12, and 1 pin joint. So here the reaction component 2, 12 plus 2, this is equal to 14. So total number of external reaction components are equal to 4 into 3 plus 1 into 2 is equal to 14. Then you can find out the total number of unknown. Total number of unknown is equal to total number of unknown member forces plus total number of external reaction components is equal to 34 plus 14 is equal to 48. Then you have to find out the total number of equations that you have to find out by taking joints and the supports. So here you have to count the number of rigid joint and the number of pin joint. Count here the number of rigid joint. This one is rigid, this is rigid, this is rigid, this is rigid. 4, 5, 6, 7. So 7 rigid joint, and count how many pin joint? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 pin joint and 7 rigid joint. Number of rigid joints 7, number of pin joints 7. Then you know that is at rigid joint there are 3 static equilibrium equations available, and at a pin joint there are 2 static equilibrium equations available that you can find out from the table 2. This one, table 2. So number of static equilibrium equations for different types of joint. For rigid joint and for plane frame 3 equations, and for pin joint and plane frame there are 2 equations. Number of equations of static equilibrium 2. Then you put the value of number of rigid joints and number of pin joint and find out the total number of equations of static equilibrium. 7 into 3 plus 7 into 2 is equal to 35. So this is the total number of equations of static equilibrium that you got from the total joint system, total joints and support system. Then you can find out the degree of static indeterminacy. So is equal to total number of unknowns minus the total number of equations of static equilibrium. So here you got the total number of unknowns 48, and here you got the total number of equations of static equilibrium 35. 48 minus 35 is equal to 13. So this is the degree of static indeterminacy of these hybrid structures from the second approach. So in first approach also you got 13, and also second approach you got 13. So then coming to the second problem, determine the degree of static indeterminacy of the hybrid plane frame. So this is the hybrid plane frame, and here this is the hinge support roller, and this is the fixed support. And here you have to find out the total number of independent external reaction components. Hinge support there are 2 reaction components. At roller support there is 1 reaction component. At fixed supports there are 3 reaction components. So total number of reaction components are equal to 2 plus 1 plus 3, 6. Then find out the degree of external indeterminacy. DSC is equal to R minus 3. So here R is equal to 6 minus 3 is equal to 3. This is the degree of external indeterminacy. Then find out number of pin joints. So here the pin joint 1, 2, 3, 4, A, B, C, D. The number of members meeting at each of the pin joint A, B, D. At A there are 2 members meet, at B there are 2 members meet, at D there are 2 members meet. So ABD there are 2 members meet. The number of members meeting at each of the pin joint ABD is equal to 2. Similarly, find out the number of members meeting at each of the pin joint C. At C there are 3 members meet. So C, this is equal to 3. Then find out the summation of m minus 1. So summation of m minus 1. So here there are 3 joint where 2 members meeting. So 3 into 2 minus 1. M is the number of members meeting at the joint. So how many? So here there are 3 members. There are 3 joints where 2 members meeting. So 3 into 2 minus 1. Here there are 1 joint where 3 members meeting, plus 1 into 3 minus 1. So the summation of m minus 1 is equal to 5. But you know, for the rigid jointed plane frame, if the structure is open configuration, then that is statically determinate. If the structure is a closed configuration, then that is statically indeterminate. So here you have to find out the degree of static indeterminacy by making one cut here to make the structure is your open configuration. So C is equal to 1. So you can find out the degree of static internal indeterminacy DSI is equal to 3C minus summation of M11. DSI is equal to 3C minus summation of M minus 1. So C is equal to 1, 3 into 1 minus summation of M minus 1. Here you got the summation of M minus 1 is equal to 5. So 3 into 1 minus 5 is equal to minus 2. So the degree of static indeterminacy that you can find out by taking the degree of static external indeterminacy, then by taking the degree of static internal indeterminacy. So the degree of static indeterminacy is equal to ds is equal to dsc plus dsi, and dsc you know 3 and dsi you know minus 2. 3 minus 2 is equal to 1. So this is the degree of static indeterminacy of this hybrid structure. Also you can find out using the other approach, second approach. So here you have to find out the total number of unknowns, that is the member forces plus support reactions. So here you have to count the number of members with rigid joint at one end and pin joint at other end. You have to count number of members with rigid joint at one end and pin joint. This one, this is rigid joint and this is pin joint. This is one, and here this is both ends are pin joint, and here also both ends are pin joint, and here also both ends are pin joint. So 4 members, both ends are pin joint, and 1 member, one end is rigid joint and another is pin joint. So here the number of members with rigid joint at one end and pin joint at other end, this is 1. Similarly, the number of members pin joint at both ends, 4. Then you can find out the total number of unknown member forces. So you know that is at rigid, if one end is rigid joint and the other end is pin joint. So here how many member forces? So here you have to take 2 from the table 1. If one end is rigid joint and another end is pin joint, so that case, so the number of member forces is equal to 2, 1 into 2. Similarly, if both ends are pin joint, so that case the number of unknown member forces, that is equal to 1. So the total number of unknown member forces is equal to 1 into 2 plus 4 into 1, that is equal to 6. Then you know the total number of external reaction components. So here this is 3, this is 2 and this is 1. The total number of external reaction components are equal to 6. Then you have to find out the total number of unknown. The total number of unknown is equal to total number of unknown member forces plus total number of external reaction components. So here the total number of unknown member forces are equal to 6 and total number of external reaction components are equal to 6. 6 plus 6 is equal to 12. This is the total number of unknown. Then find out the total number of equations, that is from the joints and from the support. So here you have to count the number of rigid joint and number of pin joint. number of rigid joint and number of pin joint. Here this one is rigid joint, this is pin, this is pin, this is pin, and this is pin. So how many pin joints are here? 4 pin joint and 1 rigid joint. Number of rigid joint 1 and number of pin joint 4. Then you can find out the total number of equations of static equilibrium, because you know at a rigid joint there are 3 static equilibrium equations available, and at a pin joint there are 2 static equilibrium equations available. That is from the table 2 you can find out. This is for rigid joint and for plane frame 3 equations, and for pin joint and for plane frame 2 equations. So you have to take this for rigid joint 3 equation and for pin joint 2 equation, and you have to find out the number of static equilibrium equation. You have to find out the total number of equations of static equilibrium by taking the number of rigid joint and the number of static equilibrium equations for rigid joint and number of pin joint and the number of static equilibrium equations for pin joint. So here 1 into 3 plus 4 into 2 so is equal to 11. So this is the total number of equations of static equilibrium. Then you can find out the degree of static indeterminacy, that is equal to the total number of unknowns minus the total number of equations of static equilibrium. The total number of unknowns is equal to 12 and total number of equations of static equilibrium is equal to 11. So 12 minus 11 is equal to 1. The degree of static indeterminacy of this hybrid structure is equal to 1. Also you got in the first approach 1. Now all are clear how to determine the degree of static indeterminacy of hybrid structures.